Okay, today we're going to do our first bit about scatter plots. There will be two videos, but we'll do like a part one and a part two. So a scatter plot is a graph used to determine whether there's a relationship between paired data. Whether you took a survey or just collecting data about something. But the scatter plots can show trends in the data. So our first vocab word that we have is correlation. Okay, and inside correlation, we see the word relation. So it has to do with the relationship between things. So if Y increases as X increases, then the data has a positive correlation. And if you look at that line that's going through the data, we'll talk about that in a little bit, but that line has a positive slope. So if you would draw that line and it has a positive slope, that's going to be a positive correlation. The next one is when Y decreases, Y goes down as X increases. We always talk about as X increases, what happens to the Y. So in this case, as X increases, the Y goes down, and that has a negative correlation. And that line that they drew through there has a negative slope, so it would have a negative correlation. And then if X and Y have no apparent relationship, the points are just kind of scattered all over the place, that has relatively no correlation. Okay, there is no pairs of information you can say between one and the other. Okay, so some examples. So for our positive correlation, your height increases as your age increases. Now, obviously, that's up to a certain point, but as you're a little kid and you're growing, your height tends to go up as your age also goes up. And also, the population in New Jersey has increased over the years, meaning as time increases, population increases. So if you were to connect your data points and put your data points on a graph, they would have that positive trend as X increases, Y increases as well. Our examples for negative, the amount of money left in an account after spending over time, meaning as time increases, the amount of money in your account would decrease, unless you obviously put more money back in, but we're just assuming you're spending that money, so it's going down. Also, a population of endangered animals decreases over time, meaning as time increases, the population decreases. Okay, and then lastly, for our no correlation, if you put together your house number and the number of pets you have, like there would be no trend going on there. Okay, you could have a high house number and low pets, or uh, high house number, lots of pets. It doesn't matter. They aren't related to each other. And also the number of siblings you have and the number of students in a school. Like that doesn't affect each other. So it says at the bottom, one does not determine or affect the other. So those are our three types of correlation. Oops. Okay, and now we are going to look at the bottom, which is where you're actually going to do a teeny bit of math today. So we have a graph here, hours worked and the grade, okay, for a time spent on report grades. Okay, so it's also good to A, look to see if there's a title, B, look at the axes, see what the axes are representing. Okay, and please note that line there was not there originally. Okay, it was just those red dots representing how many hours someone worked on a report and what the grade they got was. Okay, that line that was drawn in there is called a couple things. It could be a line of best fit. You might see the words trend line. You could see regression line. All of those are saying the same thing. It's the line that best matches the data. Okay, it tries to go through the middle of the data. It may or may not go through actual data points. In this case, it does go through them, but your trend line could definitely go through the middle of your data without actually hitting some of your data points. Okay. I am never going to make you draw the line. It's going to be given to you, or maybe we end up using technology to calculate it. But you're not going to have to sit there and like use a ruler and try to figure out where it goes. Okay. What you will have to do, like this example, is to use the information given to you to give me the equation of that line of best fit. But luckily, even though it's related to these new scatter plots that we're talking about, it's exactly the same of what we've been doing for the past month or so, which is to just take your 2 points, find a slope, and then figure out what the y-intercept would be. Okay, so let's use those points there. Let's do our slope. So y minus y over x minus x. So I'll do 85 minus 70 over 4 minus 2. That's going to give us 15 over 2. Now, normally if this was not a scatter plot, we would just leave it as 15 over 2 because we do keep our slope improper. But when we start doing those real life scenarios, we are allowed to write it as a decimal because now it actually means something. So I'm going to write it as 7.5. And now I'm going to plug things into y equals mx plus b. And remember, it does not matter which one I use. I'm going to use my smaller numbers. So I'm going to say 70 for my y. My m was 7.5. My x was 2. And plus b. I do want to note before I actually do that calculation, notice that break in the graph. Okay, so we could not extend our line and see where it's hitting because it has that jump from 0 to 60. We don't know what's going on there. Okay, if it was a graph where the full amount of data was on that y-axis and it hits it at a nice spot that you could actually tell what it is, then by all means you can use that y-intercept. But here there's that jump and we cannot do it that way. So we're going to plug things in. So we got 70 equals, that would be 15. So 15 plus b, we would subtract our 15 and get b equals 55, which means our line of best fit is 7.5x plus 55. And that is where we are going to stop with part 1, and you are going to do a little bit of practice. And then next class time, we will talk about using technology and doing part 2.